We're going to continue talking about continuous functions today because we actually only talked about half of the types of continuous functions you might see. Today we're going to be dealing with what are called unbounded graphs, but we'll get there in a second. Before we get there, we're going to review some of the vocabulary that we need for today. Now you see Dr. XY wears her ID over here on the left, and remember that Dr. XY wears her ID helps us remember that the domain is the x variables, which are the independent values or your inputs, and it helps us remember that the range is the y values or your dependent values, so your outputs. Last time we also practiced the fact that domain is describing a continuous graph from the left to the right, and that range is describing that graph from the bottom to the top. We defined continuous functions to be functions that are connected together on the graph. Continuous means connected. These are independent variables that we can measure. Think time, distance, temperature, and units. We defined domain to be the set of all inputs or x's, which makes sense from Dr. XY wears her ID. And range is the set of all outputs or y's. We also talked about writing the domain and range for continuous functions as an inequality. We're still going to use this pattern today. So remember that this pattern is, in the blanks, you either write the left or the right number for the domain, or the bottom and top number for the range. In the triangles, you do have to pick one of the following inequality signs to go in the triangle. If you see a closed circle or see that the graph exists there, you're going to have to use a less than or equal to symbol. If you see an open circle, you're going to use just the less than symbol. Again, these two things go in the triangles for the left and the right, or the bottom and the top endpoints for the graphs. But the continuous graphs that we used last class all had endpoints on the left, right, bottom, and top. So what's going to happen if we have a continuous function that looks like this? This particular function has an endpoint on the left or on the bottom, but if you look towards the right or if you look towards the top, you have an arrow. An arrow means that this graph is going to continue going off screen forever and ever and ever. So we have to do something different with the arrows. Arrows mean no endpoints. It's going to continue off screen if you were to type this in Desmos, or continue off screen from what we can see that's printed on your paper. The arrows mean no endpoints, and that it keeps going and going and going and going. So we don't have an endpoint on that side, so something new and different is going to happen. We're going to describe its domain and range just a little bit differently. These are called unbounded graphs because they don't have bounds or endpoints, and we know that we have an unbounded graph if we see the arrows, like this first graph, you legitimately see the arrows printed on the graph, or you know that the graph keeps going off screen, so extends off screen. Like this graph that's red. We don't see the arrows, but you can tell there's no endpoints, so it's almost like we know, or we could draw in the fact that arrows exist. Because if we were to zoom out on this graph, it would continue to go all the way to the left and bottom, or right and top. It would keep going off screen. And if this is the case, then when we're dealing with graphs that go off screen or that you see arrows, we're going to have to use an infinity sign to describe the where it's going, or a negative infinity sign. Because that's where this graph is headed towards. What I mean by that is, if we were looking at the domain for this graph, remember we're looking at the x's. I look to the left and I see an arrow, which means this is going to keep going and going and going and going and going and going and going. The number that it's going to keep going and going and going and going and going to is negative infinity, because it's going to continually move this direction. It's going to continually go on an angle, but out this way. Those are negative numbers, so I'm going to eventually reach or head towards negative infinity. If I look on the right side, and this arrow going that way forever, never, 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 never going to stop, it's headed towards positive infinity. If we look at its range, so bottom to top, the very bottom is still an arrow, so that arrow is going to head down and down and down and down and down. That's still heading towards negative infinity. And the top going up and up and up and up and up, we never find the top of it. It's headed towards positive infinity. Same thing with the red graph. On the x-axis, it's headed towards negative infinity to infinity. And on the y-axis, it's headed from negative infinity to infinity. Literally everywhere. When we're dealing with infinities in our blank triangle box, triangle blank scenario, if you write an infinity sign in those blanks, you're going to use the less than symbol. Okay, infinities goes with less than because we never actually reach infinity. It's more of an idea. It is a number that we can't count towards, so we're never going to reach it. So we're always just going to use the less than sign, not less than or equal to, because we can't ever actually equal infinity. It's too big of a number or too small of a number. So let's look at some examples, because these still are kind of different. We're going to look at that graph that we were just playing with a second ago. And remember, we're trying to fill in this pattern. Blank, triangle, box, blank, triangle, blank. For the domain, remember, that is the left to the right. Okay, let's look on the left. Here's the left of the graph right here. That is at the point 0. Oops, didn't mean to do that. It's at the point 0 on the x-axis. So we know my domain starts with 0. And it's a closed circle, so I use the close symbol, which is the less than or equal to. Talking about domain, so this is going to be x. But if I look at the right, I see that there's an arrow. It's going to keep going and 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 getting bigger along my x-axis, which means that this is actually headed towards positive infinity. So I have less than infinity. That is where it's headed, from 0 to positive infinity. But in this class, you're not going to use infinities in your final answer. So what I would like you to do is highlight the infinity signs and the inequality sign near it, and then don't include that part in your final answer, which means we would have the inequality x greater than or equal to 0 whenever we flip that around to have the x coming first. 0 less than or equal to x is still an acceptable answer, but for the most part, you will see these inequalities with the variable coming first when they are single-sided inequalities. Let's check out the range. If you remember, range is bottom to top, so we're going to look at the bottom of this curve, of this line, and the bottom's right here. That's at the value 1. Okay, so there's my bottom number, and it's closed. This is the range. But if I look at the top, I see again that this graph is going to continue going and going and going and going and going forever and ever upwards, which means it's headed towards positive infinity. So less than infinity. That's my top number. I followed the pattern of line, triangle, box, triangle, line, but you hear my voice in your head saying, wait, you cannot include infinity signs in this class. So we're going to just ignore it and either answer 1 less than or equal to y, which is acceptable, or the more common answer of y greater than or equal to 1, which is just flipping the whole thing around so the letter comes first. Gist of today is if you know that the graph keeps going on and on and on off screen, you're going to reach either negative infinity or positive infinity. But you don't include those in your final answers for this class. You're going to pretend like they don't exist and just write it as a single-sided inequality. Let's look at this next example. This next example, I don't see arrows on the end, but I'm going to go ahead and draw them in because I know that they're there and that this graph continues on to the left, to the right, to the bottom, to the top. If I were to zoom out, it would keep going. So let's talk about the domain. The domain is the left to the right. If I look at the left of what I see of the graph, I see an arrow. Whoa, that means it's headed towards negative infinity. So that's my first blank. Negative infinity less than x. If you look on the right side, so headed to the right, you also see that there's an arrow. And since it's headed towards the positive numbers on the right, it's headed towards a positive infinity. And I'm sure, like Miss Quigley, you just told us that we're not allowed to include infinities in our answer, and if we took those away, we'd just have a single x there. You're right. And what that means is that there are no boundaries on the x's that are used for this particular function, and that you would answer that the domain is all real numbers, which means any number that we can think of is a part of this domain. When we learned about all real numbers when we're solving equations, we had the fun and funky all real number symbol that I accept as part of your answer. You can totally use that symbol. So if both sides are infinities, that means you have no number that is not going to work. It means it works everywhere, so that's all real numbers. Let's check the range now. So we're looking from the bottom of the graph to the top. Well, at the bottom I still see an arrow. That's negative infinity. And at the top I see an arrow headed towards positive infinity going up. So our range is still going to be negative infinity, which is less than x, which is x. Whoa, should be a y there, sorry. So negative infinity less than y, less than positive infinity. But you hear that I said infinity twice, and that means it doesn't have either side of this inequality, so we would answer all real numbers. This graph never stops any direction, so its domain and range happen to be all real numbers. You guys are going to try this next one on your own. Just this one right here. Stop the video and give it a shot. Does this graph have any endpoints? None that I can see, so let's start our process. If we look at the domain, we're looking from the left to the right. Well, on the left over here, I see that it's an arrow headed towards the negative numbers, so it's headed towards negative infinity. And on the right, I see that it's headed towards all the positive numbers with an arrow, so that's headed to positive infinity. Filling out our pattern, we have negative infinity less than x, which is less than infinity. But we remember that we cannot include infinities in our answers for this class, so we're going to answer all real numbers. Or the fun and funky r, also acceptable. Checking out the range, if we look at the bottom of the graph, the bottom is over here, but that bottom is still headed towards the negative numbers, which means it's headed towards negative infinity. The top, headed upwards, this is the top of the graph, is headed towards positive infinity. So our range is still negative infinity less than y, which is less than infinity. But since both sides are infinities, we're actually just going to answer all real numbers again. One more time, y'all stop the video and try this last example on your own. So here's my thought process. I looked at the domain, so I looked at the left, and know that this graph is headed off screen towards the negative numbers of the x-axis, so I know it's headed towards negative infinity. But on this other side, on the right, I see that there's an open circle at the value of 3. So when I fill in my domain, I'll use the left value of negative infinity and a right value of an open 3. But I need to finish this out. I realize that there is a negative infinity on this side, so I'm just going to answer the side without the infinity. X is less than 3. Double checking that since I have an open circle right here, that I leave the open symbol, which is less than. Additionally, for range, you should notice that the bottom is heading downwards towards the negative infinities, and the top is approximately 2.75, because it's about 3/4 of the way between 2 and 3. So for my final answer, I'm not going to include the infinity part. I'm just going to say y is less than 2.75. Or if you're like me and you like fractions, you can say y is less than 11/4. Either are acceptable answers in this case, either with the decimal or fraction answer. So all in all, the gist of today's lesson is that if you have unbounded graphs and they go off screen, that you are actually headed towards either infinity if you're headed towards positive numbers or negative infinity, and that you include the less than sign for your domain and range. But we don't include or leave those parts in our final answer. And so you just kind of ignore all of the infinities over here and write your answers without them. Arrows means it keeps going off the graph. Just like last time we saw that puppy and I asked you to let me know where the puppy is, this time we have Elastigirl on the screen. You guys could still tell me the domain and range of Elastigirl. Because if I asked you for where to put her side to side, you'd say, well, Miss Quigley, make the very end of her fist at about -10. And then I would say, okay, well, where does she end on that side? And you say, well, Miss Quigley, she's Elastigirl. She's going to continue to go off screen that direction towards positive infinity. So we would know that her domain is from -10 inclusive to infinity. But we don't include this part in our final answer, and we'd say that Elastigirl is all above -10. If I asked you where to put her on the range, you'd say, well, Miss Quigley, she kind of goes off screen down there and she keeps stretching and stretching and stretching. So she's headed towards negative infinity because she's going down. That's the bottom. And you could say, well, the very end of her hair is right at -2. So that's where the top should be. So her range should be from negative infinity to 2, but you don't include the negative infinity in how you'd answer this. So you'd say, Miss Quigley, the entire graph is below and touching 2. I would know exactly where to place Elastigirl on this screen, giving her fist and then her leg extending off screen, and the very top of her head, and her fist extending all the way down to negative infinity. So it works just like the puppies. It's just that Elastigirl is going to keep stretching and stretching for forever and end up at either infinity on the x's or negative infinity going down on the y's.